and today we're going to be talking about classifying numbers into different sets of numbers. So you might have seen something similar to this in biology class when you're talking about classifying different organisms into different categories, right? And you had kingdom, phylum, class, species, subspecies, those types of things. Well, now we're going to be doing basically the same thing, the same general concept, except instead of classifying organisms, we'll be classifying numbers. So we'll start with the very basic ones, the natural numbers, and work our way up to the entire set of real numbers. Okay. All right. So we'll start with the basic one, and we'll start with the set of natural numbers. N for natural numbers, right? And so since we're doing the natural numbers, natural numbers start. Whoops, put an N in front. Natural numbers start at 1, and they work their way up to infinity. Okay, and so they don't have any negative numbers, and they also don't have any fractions or decimals. They just have, starting with 1, working their way up to infinity. No 0, no negatives, no fractions, nothing like that. Okay, and so these are the counting numbers, right? If you ask a kindergartner to add 3 plus 4, they would start with 3 in their hand and then add 4, right? And so these are the counting numbers, the most basic set of numbers that we have. Beyond the natural numbers, we have the whole numbers. W will be for whole, okay? And so the whole numbers are very, very, very similar to the natural numbers, except instead of starting at 1, these guys are going to start at 0, and they will also work their way up to infinity. Now, these again do not have any fractions or decimals in there, and they also do not have any negative numbers. They just begin at 0 and work their way up to infinity. And I know what you're thinking. These two sets of numbers are very, very similar, and you're absolutely correct, right? If a number is in the set of natural numbers, then yes, it is definitely in the set of whole numbers, right? That's kind of what our diagram is starting to do over here, where we have the natural numbers inside, and then, of course, if something is inside that little bubble of natural numbers, then it is definitely inside the little bubble of the set of whole numbers, right? And so that's what we're doing. We're starting on the inside and kind of working our way out, okay? Beyond the whole numbers, we then have the set of integers, and this is probably the one that we're all most familiar with. I'm going to use a Z for the set of integers. Okay, and integers is going to start, well, it really doesn't have any starting point. Integers includes all the negative and all the positive whole numbers, right? And so this goes from negative infinity all the way to positive infinity, but still it doesn't have any fractions or any decimals, okay? So just negative 10, negative 5, negative 1, 0, 1, 7, all the way up to infinity. From negative infinity to positive infinity. It's the set of integers. Okay? And then beyond the set of integers, I have the set of, I'm going to put a Q here. And that Q is going to stand for rational. Q is going to stand for rational. Okay? And rational numbers are anything that can be expressed in terms of a fraction. Okay? So an example of a rational number, I'm just going to give specific examples. This would be 7 over 3 would be a rational number. Maybe another type of rational number would be negative 3, right? That is also a fraction technically, right? Just being divided by 1. And then maybe we have 113 divided by 7, right? That's a weird rational number, but it's still a rational number in general, right? So maybe I'll even make a note next to that rational where a rational is, it can be a fraction or it can be a repeating decimal. Okay, and so if it can be written as a fraction or a repeating decimal, then yes, it is definitely a rational number. Okay? All right, and then the next one beyond rational numbers would be the irrational numbers, right? Because if you're not rational, then you are certainly irrational. And for irrational, I'm going to use an I. You might see irrational be written with an I or a P in some cases. Okay, so an irrational, come on. An irrational is essentially the opposite of a rational number, right? And so since rational numbers are either written as fractions or repeating decimals, then that means irrational numbers cannot be written as fractions or repeating decimals. So some examples of some irrational numbers would include, how about 0.713 ... and it goes on forever, right? It never repeats or ends, something like that. Pi would also be an irrational number because pi, as we all know, never repeats and it never ends. It just goes on forever, right? 3.1415 forever. And so maybe I'll make a note next to irrational. Whereas these guys, they never repeat, and they never end. Okay? And then one last example I'll give of some irrational numbers would include a square root. Let's do a square root of 37, right? That square root of 37 would be an irrational number because the square root of 37 is some weird number. Type it into your calculator, it's like 6.1, I don't know. It goes on forever though, and it never ends and it never repeats, right? And so since that square root really cannot be simplified, I know that that must be an irrational number because it never ends and it never ever repeats, okay? Now, the very last one we have, probably the most interesting, is I'm going to label it as R, and R will be the set of real numbers. And the set of real numbers really just contains everything, right? It's everything that's within this diagram, right? So maybe it's a number that falls there, or it's a number that falls just as a rational, or maybe just as an irrational, whatever. But if it's a number, meaning just about everything that you've ever seen in your life, it is definitely a real number. Now, okay, so we're not going to talk about any complex numbers or imaginary numbers or lateral numbers, some of us call them. We're not getting into that in this section. That's for another time down the road. Right now, we're just limiting it to these 6 sets of numbers.